guys, welcome to today's video. Today we are going to do observations, discuss about the observations. First thing we are going to do is we are going to understand the observations of some basic gases. Basic, not that basic which you are thinking acid basic. Okay. First thing, if there is O2, what will you write as observation? O2, what can you write as observation? Then for O2, observation will be it rekindles a glowing splinter. It rekindles a glowing splinter. Okay, this is the observation for O2. So when you get no other observable products, then you have to write O2 if O2 is present, but only in which case? Only if there is no other observable product. Okay, so the first one was O2. Second one is hydrogen. Hydrogen, what observation? It burns with a pop sound, right? It burns with a pop sound. It burns with a pop sound. Correct? Now let me tell you that both these gases are colorless and odorless. So when you are writing it, do not forget to mention that. Okay, when you are writing it. So here you will mention colorless and odorless. Clear? These two gases H2O2 are colorless and odorless. So whenever you are writing it, you must mention it. Clear? So colorless odorless gas evolves, which rekindles a glowing splinter is O2. Colorless odorless gas evolve, which will burn with a pop sound is hydrogen, that is H2. Okay, next. Third one. Third one is SO2. How will you identify that a given gas is SO2 gas? To identify that a given gas is SO2 gas, you have to mention two things in your answer. First one, that it is a colorless gas, it's fine. But if you write odorless, it is going to be wrong, because this is not an odorless gas. So it's colorless gas, it's absolutely fine. So colorless gas which turns lime water milky. Yes, it is correct, lime water milky, fine. But you cannot write this as an observation, this portion. Why? Reason. This portion cannot be taken as the answer. Why? Because there is another gas, our favorite gas. This person also does the same thing. Then how will you distinguish between them? So this thing cannot be taken as the answer. You cannot write this thing as the answer. Then what should we write as the answer? Yes, definitely we will answer the question. That if this is not the answer, then what should we write for the answer, right? Then for the answer we will write that colorless gas evolves. Colorless gas evolves which turns lead acetate paper black. Lead acetate paper black. Clear? Acha. Since we have told that this gas does not have any odor, so what thing you can write about that? You can write about an odor. You can write about its odor. Okay, I am writing here at the side. You can write about its odor. What will you write? You will mention it in the answer only. Okay, what will you write? You will write burning smell of sulfur. Clear? This is sulfur. Okay, so this particular gas has a burning smell of sulfur. Clear? So this gas will turn lead acetate paper black, then it is SO2. Both will turn lime water milky, SO2 and CO2. But who will turn this paper black? That is SO2. Clear? Understood? Next, moving on to CO2. Fourth one, CO2. As we have already discussed, turns lime water milky. Clear? So we will be writing turns lime water milky, because by general we take lime water milky is CO2, SO2 is having a burning smell of sulfur, and it will turn lead acid paper black. Clear? So simple observation, turns lime water milky as of now. Okay, as of now this is okay. Clear? But generally do not have to write CO2 observation. Generally I am telling. Okay. Okay. Next, number 5. Number 5. NO2. You will get this in HNO3. Generally NO2 will be coming as a answer. So NO2 you will be writing reddish brown. Okay, reddish brown gas or reddish brown fumes also you can mention, but it's reddish brown gas. Clear? So answer is reddish brown gas, NO2. NO2 observations are generally present in HNO3 reactions. There you have to write NO2 as reddish brown gas evolves. Clear? NO2. Next, H2S. This person is rotten egg smell. Everyone has literally memorized it. Rotten egg smell. So a gas evolves which has a rotten egg smell. H2S. So these are some of the basic gases, not that basic, acid basic. These are some of the basic gases that you need to remember with their observation. So if no other observations is present, no other observable products are present, then you have to mention these gases. Clear? Observation. Okay. If no other visible observations are seen in the particular reaction, please note it. Okay. Now we are moving on to the reactions which has some other products with a characteristic. Clear? Basically more or less questions will be coming from analytical chemistry. Okay, first one is CaOH whole twice. Where do you get this product from? CuNO3 whole 2 and NaOH gives you CaOH whole 2. Correct? So generally question will be given, what do you observe when calcium nitrate is added to caustic soda? Direct question will come. Answer will be white precipitate which is sparingly soluble. Definitely a precipitate is not soluble, but this is very less soluble. So it's sparingly soluble. Clear? So next observation, question will come is that what happens when ... Okay, I am not writing the entire question. It's what happens when ... Okay, this is added to this. Then you have to write the answer. As answer, you will be writing the color. Clear? Answer must be color. Please note it. Answer must be the color, because this will generally have one color, right? So that has to be written in the answer. Otherwise, you will go wrong. Clear? So answer needs to be the color. Okay. Let us see. First one I told you was CaOH whole twice. Color is dull white. In your book it is white, fine, you can write white also. Okay, color is dull white. How do you get it? You get it by heating CaNO3 whole 2 with NaOH. If you do that, you will get the result as CaOH whole twice plus NaNO3, where this is colorless, this is having this color is this is caustic soda, this doesn't have any color. Clear? So what is the color of CaOH whole 2? Dull white. What happens when you add calcium nitrate to sodium hydroxide? White color precipitate is formed. Clear? Next. Iron. Very important question. Iron shows variable valency. Do you know that? Fe2 plus Fe3 plus. I have already told you in analytical chemistry. So two types of salts will be formed. One is Fe2 plus, one is Fe3 plus salts. Fine. So one salt we have is FeOH whole twice, that is standing for this person, and another one is FeOH whole 3, is standing for this person. Clear? Now FeOH whole 2, whenever you see, you will have to remember that the answer is dirty green. Clear? Dirty green PPT. PPT is obvious, so this color is dirty green, very important. And whenever you see this person's color is reddish brown. This color's person is reddish brown. Clear? FeOH whole twice always has a color dirty green precipitate. Okay, and Fe2 plus originally iron had the color pale green. Okay, and Fe had the color yellow only, so it becomes reddish brown. Okay, Fe3 plus iron. Clear? So FeOH whole twice is dirty green, while FeOH whole 3 it is reddish brown in color. Now how are they being formed? Reaction I have already shown in analytical chemistry, but I will still show it once again. FeSO4, if you add it with NaOH or NH4OH, this will give you the same reaction anyways. Okay, this will form FeOH whole twice, because here the valency is 2 plus. Clear? Acha, plus. Now depends. Na, if it is NaOH, then it is Na2SO4. Fine. Now if it is ammonium hydroxide, then it will be NH4 whole 2SO4. Clear? I am writing the ammonium reactions as well simultaneously. Okay, understood? Clear? Now let me move a little bit back. Up I had written the reaction for calcium, but here I have not mentioned NaOH. Why? Sorry, NH4OH. Why? The reason is no reaction with NH4OH. Clear? No reaction with NH4OH. Why? NH4OH is a weak acid. So it cannot produce much H plus ion, so that it can displace the OH minus ions of calcium. Calcium hydroxide is there, so just like any salt is there, so it cannot displace that OH minus from ion, because NH4OH is a very weak acid. Clear? So no precipitate will be formed. Will not be formed. Rather, this has to be first displaced. Then only the hydroxide will be formed. But this is not only displaced. How will hydroxide form? No, precipitate cannot form for calcium in NaOH, NH4OH. Clear? Understood? That is why I have not written the reaction. Okay. Move back. Clear? Okay. Next, instead of FeSO4, if we take FeCl3, remember the color of FeCl3 is yellow. Okay, FeCl3 is yellow in color. If we add that with NaOH or NH4OH, product becomes FeOH whole 3 plus NaCl, okay, or NH4Cl. Understood? Depends again on what is it being formed. Clear? So this color already mentioned, reddish brown. This color is yellow. Now we will find this FeCl3 is kept in airtight bottle. Why? Reason is very simple. It's a deliquescent substance. Okay, remember this also. Deliquescent substance. This FeCl3 can easily form a solution, saturated solution. So we are keeping it in airtight bottles. Clear? Remember these two things, because this is a very important thing. Next, in case of ammonium hydroxide, you can even add Fe2S4O3. That is also will work. That will also do the same precipitate. That will be ammonium sulfate as the product. What I mean is this. Instead of writing FeCl3, we can write it as Fe2SO4 whole 3 plus NH4OH. That will also give you the same product, FeOH whole 3 plus this product will change, that is NH4 whole 2SO4. Understood? This can also be done. Okay, but this is, remember, this person only, not NaOH. Clear? That you have to take care of again. Done. Iron salt sorted. Now next is which salt? Copper salt. Copper has only one ion, that is this. Okay, so copper salt color is blue. Obviously, everyone knows that, blue, right? Now let's see one reaction. CuSO4 color, everyone knows, blue, right? CuSO4 is blue. Added with NaOH or added it with NH4OH. Clear? NH4OH. What will it result? CuOH whole twice. Correct? Here also CuOH whole twice. Product will not change. This product will not change at least. Now NaSO4 does not come, so it will be Na twice SO4. and if it is ammonium hydroxide, then the product will be NH4 whole 2SO4. Clear? This person is a PPT. This person's color you need to locate. What is the color of this person? Pale blue. Okay, focus on the word pale. Obviously copper salts are blue in color, but this person is pale blue in color. That you need to take care. This person is pale blue in color. Okay, understood? Next we move on to zinc salts. Zinc salts. Zinc also has only one ion as of now, Zn2 plus. So zinc salts will be forming a precipitate white. That you have to remember. White precipitate. Yes, fine. White precipitate. Okay. But what type of white? It's a gelatinous white. That thing you need to remember. What type? Gelatinous white. What type? Gelatinous white. See, we will be learning three types of white. One is dull white. One is gelatinous white. I'm just writing, okay. One is gelatinous white and one is chalky white. If you can remember that who is under whom, then it will be very easy. Dull white, as of now we have learned about calcium. Gelatinous white we will be learning about this person. Clear? And chalky white will be for this. If you can remember this three, at least whatever salts will be given with zinc, you can just put it from here. Okay, if you can remember this thing only, that zinc is gelatinous and this thing dull white calcium, gelatinous white zinc, chalky white lead, then you can just put it from here. Understood? That depends on if you can remember or not. Okay, if you can remember, very well. If you cannot remember, then nothing to say. Okay, let's move down now. Okay, so zinc, which salt do we take? Sulfate. Generally it's sulfate. Zinc sulfate added with NaOH first, because this will not yield the same product in case of NaOH and NH4OH. Okay. This will give you ZnOH whole twice plus, okay, this is little. Clear? Whenever I am not writing anything, that means it is little. Please also note that. Here I have not written anything, that means it was little. Okay, because copper sulfate will change its products. I have not yet shown the excess one. All this we are doing is little. Okay, all this we are doing is little. Okay, excess I have not yet shown, so be careful with that. I am showing all little now. No need to confuse yourself. Little. Okay, all little products have been shown now. Excess I have not yet added also. Okay, so ZnOH whole 2 plus NaOH little will give you ZnOH whole 2 plus Na2SO4. Fine. Next, ZnSO4 plus NH4OH, that 2 in little, will give you ZnOH whole twice plus NH4 whole twice SO4. Correct? Okay, these are all little products. So what is the product formed as of now? This color is what? Gelatinous white. So whenever you find zinc, you will mention gelatinous white. Okay, so what is the color of this product? Gelatinous white. Okay, color of this product is gelatinous white. Now let us move on to the next product, that is the second last product, that is lead iron. Clear? Lead iron. We are bothered with Pb2 plus. I know there is someone else also, but we are not bothered with Pb4 plus iron. We are bothered with Pb2 plus iron. Okay. Pb2 plus ion. We will take lead nitrate, heat it with NaOH at first in little quantity, done, sorted. Then this added, we will be getting a product of PbOH whole twice plus NaNO3. Alright, this color, as I have already said before, that lead will give you a chalky white PPT. Okay, so lead gives you chalky white. So PPT form this chalky white. PPT, who is a PPT? This person is a PPT. Clear? This person is colorless, so you cannot detect that. This person is PPT. Okay. Now what will happen in case of lead? In case of ammonium hydroxide, in lead, same product. Clear? Same product, no change in the products. So let's write Pb NO3 whole 2 plus NH4OH will form PbOH whole twice, color remains same, plus NH4 NO3. Clear? This color remains same. Done, sorted. Now one extra is there, that is for your NaOH. That is, whenever you add caustic soda, not only caustic soda, caustic potash also, or rather I will say alkalis, to ammonium salt. Ammonium salt, suppose we are adding it with NaOH, we will get required salt plus NH4OH. See here properly, NaCl gone. So we are getting this percent NH4OH is very unstable, so it will decompose into NH3 gas plus O. This nascent oxygen will not stay. Where will hydrogen combine with this hydrogen? What will it form? H2O. Clear? Understood? So this nascent oxygen will not stay again. So this will be combining to form water. So what we will be writing instead of this? Water. Clear? So we are going to write this person and not this person. Okay? Do not write this person in the answer. Write this person. So NaCl plus NH3 plus H2O will be the product. Now instead of this, you add CaOH whole twice. That will also give you the same product, ammonia, and that is the laboratory preparation of ammonia as well. Understood? Clear? You add CaOH whole 2 also will get the same product, nothing different, no same product. Clear? You will add CaOH whole 2, that is in the laboratory preparation of ammonia. Okay. Now all little done. Now we are going to move on to the excess. What will happen in excess? First salt we had done was calcium. Clear? So we had seen that in case of little is L. Okay, L is little. We have seen that there was a dull white PPT. Correct? There was a dull white PPT in little. Now in excess what will happen? This will remain the same. No change. Clear? There is going to be no change in case of this. Clear? No change. Understood? So what was the reaction? Reaction was CaNO3 whole twice plus NaOH excess. Now it's excess. It will also give you CaOH whole twice plus NaNO3. No change. Understood? No change. This product remains as it is. Understood? Excess done. First salt, ammonium hydroxide, no reaction is happening only. Okay. Next we had learnt about Fe2 plus and Fe3 plus. Correct? First one was little, for this was dirty green. Excess same. Clear? Excess same. So reaction was FeSO4 plus NaOH slash NH4OH, both in excess. Okay, will give you FeOH whole twice plus NH4 whole 2 SO4 or Na2SO4. Okay, depends on which one you want. Clear? Which one you are writing down. Okay, understood? Next was Fe3 plus. So when you add Fe3 plus, we have seen that in case of little, color was reddish brown. Color was reddish brown. In case of excess, no change, color remains same. So reaction also remains same. Fe, this was yellow, you remember, yellow plus NaOH or NH4OH, both are in excess this time, excess will give you FeOH whole 3 plus NaCl or NH4Cl, dependent on what you want as the product. Clear? Sorted. Next one was copper. Okay, in case of little, acha. Now you see, copper will give you two different results. First one, let us understand, we have added NaOH. In that case, little we have seen pale blue precipitate, correct? Now when we add that excess, we will get same, no change. Very important, listen to this. CuSO4 that was blue in color, we have added it with NaOH and that is in excess. We have done it, that will give you CuOH whole twice plus Na2SO4. No change, clear? No change. But there is a big but to this. NH4OH will lead to a change. NH4OH will lead to a change. How? Let's see. When you take NH4OH, the same reaction Cu2 plus with NH4OH, we have seen last time that it was little, it was pale blue, correct? In little it was pale blue. In excess, this will be inky blue. Clear? In excess, you will find this is inky blue, or you can write it as a deep blue. Clear? Fine, both are correct. Inky blue, deep blue. What exactly happens is, this CuOH whole 2 that you have precipitated in the earlier stage in little, that if you add it back with NH4OH, then it results in the formation of a complex compound CuNH3 whole 4 bracket OH whole twice plus water. Reaction not to be memorized, no problem is there. Okay, not to be memorized with the reaction. Okay, this compound, this particular compound, not this, okay, only this much. This is called tetramine 2A copper 2 sulfate. Understood? This is tetramine copper 2 sulfate. So what do you find? That this PPT dissolves to form this, and the color of this substance is deep blue or inky blue. Clear? This is the color that we are going to write. So what change we are seeing? We are seeing that when you add this percent in excess, when you are adding this percent in excess, this percent will dissolve to form another percent, that is clear. Understood? This is the first very important observation that you need to remember from it. Very important observation, very important. Okay, next. Copper sorted. Next was lead. Lead. Okay, first let us take NH4OH this time. It's very sad. Okay, little we have seen that we have got a chalky white PPT, correct? Excess you add remains same, no change. That is lead nitrate plus NH4OH will give you lead hydroxide plus NaNO3. This color was chalky white. Clear? No problem is there? Okay. Okay, this is in excess. Okay, remember this. This is in excess. Okay, next. The same thing when we add it to NaOH in not in excess. Sorry. First little. What was the color? Chalky white. Now when we add this in excess, it becomes colorless. it becomes colorless. Why? See, PbOH whole 2 was initially present. PbOH whole 2 was present, right? This, when added to NaOH, will form salt. This is a salt plus water. Now we will ask why. This person is an amphoteric oxide. Amphoteric, not oxide, amphoteric hydroxide. This person is amphoteric hydroxide. Amphoteric means that this person will show its both characteristics, acidic and basic, but dependent on what it is working. Okay, spelling error is there. Yes, it is amphoteric. Okay, yes, amphoteric nature. Yes, clear. So this is an amphoteric hydroxide. So here this person behaves as an acid. Why? Because this person is a base. So reaction and neutralization reaction forming is this colorless. Okay, no color. This is salt, this is water. Understood? Clear? So you have to remember this reaction properly. Very important reaction. So whenever you add in excess, PPT will dissolve. No color solution will remain. It's a colorless solution. Clear? Next, zinc. First let us add NaOH. So when we have seen that we have added NaOH in little, we find that gelatinous white PPT was formed. Gelatinous white. When we add it in excess, we find a colorless solution is formed. Okay, colorless solution. Region remains same, neutralization reaction. Okay, because ZnOH whole 2 is also an amphoteric oxide, so it will react with NaOH to give you Na2ZnO2, which is called sodium zincate plus water. Okay, this is colorless. Clear? Okay, next, NH4OH. When you have added in little, we have seen that gelatinous white PPT was being formed. Gelatinous white, very good, fine. When we add it in excess, we will find that another substance is being formed. Another substance. Which substance? Colorless substance. Clear? Colorless. But there's a product is not same. Colorless white, I accept it, but products is not same. Clear? How? There is no H. ZnOH whole 2 was the precipitate. We add it with NH4OH. Resultant is another complex ion Zn bracket NH3 whole 4 bracket out OH whole twice plus H2. Clear? Again, this is a basic, this is an acidic, so it will be forming salt plus water. Whatever salt, this is complex salt. Complex salt, which is not there in your syllabus right now. So what type of salt is it forming? Complex salt. Clear? This name is tetramine zinc hydroxide. Okay, tetramine zinc hydroxide. No need to worry because it is not there. Okay, understood? So on one hand someone is dissolving, on the other hand someone is dissolving. Product may be same, may not be same, depends on what you are going to use. Clear? Understood? So this observations is from this chapter, analytical chemistry, so you need to remember that observations. Next we are moving on to electrolysis. In electrolysis, observations are basically at cathode anode. First observation comes when you do the electrolysis of PbBr2. You find the observations at cathode. Observation at cathode will be silvery grey metal deposit. So whenever you see silvery grey metal deposit, grey metal deposit, clear? Anode. Whenever it is anode, you will find either size will decrease or something is being evolved. Here it is dark brown fumes of bromine. Clear? Br2, where will it go? It has to go to somewhere, that it will go to anode. So it will be released from the anode. So cathode size silvery grey metal deposit, and anode will be dark brown fumes of bromine gas. Understood? That is electrolysis of PbR2. His electrolysis of PbR2. Understood? Clear? Next is H2O, that I am not going to say because that is a very easy one. Clear? H2O. One side it will be H2, one side it will be O2. Both observations are already mentioned before, H2 and O2 observations. H2O is H2 and O2 observations. Clear? Already mentioned before. OH2 will come at cathode, this person will come at anode. A very important, anode, cathode. Okay, make sure you remember that also. Okay, next is your copper. Next is your copper sulfate using PT electrode. If you use PT electrode, then you will get at cathode, your observation will be pink / reddish brown metal deposit. Reddish brown metal. Clear? And anode observation will be clear observation. Observation of oxygen. Clear? No observation of oxygen? Put it down there. Answer understood? Clear? Electrode observation is also there. That is the blue color of electrode will fade away. Clear? Blue color of electron will fade away because you are gradually using up the Cu2 plus ions. Okay, very important question. Electrode, blue color fades away as Cu2 plus ions are being used up and gets deposited as Cu metal. Clear? That is why the blue color of the solution will be gradually fading, not at once, it will be gradually fading. Clear? So you need to remember that much also. Okay, now CuSO4 using Cu electrodes. Using Cu electrodes. Now if we use Cu electrodes, then cathode product will remain same as before, same whatever we have written before, but anode product will be changing. Rather there will be no product only. So we will have to write that size decreases. What will you write? Size decreases, because no valid product will be found there. Rather no product is only seen. What product will you see? In anode what happens is Cu will lose its 2 electrons, nothing else. Cu will lose its 2 electron to form Cu2 plus. What product will you write there in that case? No product. You cannot see any product. Nah. So product is nothing, but you will write only size decreases. Here. Okay. Next we are moving on to hydrogen chloride test, that you already know. That for hydrogen chloride test, if you take it near NH4OH, or not really near, but you can just dip. Suppose this is NH4OH in a beaker. Inside this, if you dip a rod, though the rod will not be like this, I am just showing. Okay, and then you bring it near a container, another container over here, inside which there is HCl gas. You bring the same rod over here, maybe near the mouth, then we will find that there is here this portion dense white fumes will be seen. What will be seen? Dense white fumes. This dense white fumes that is visible is the NH4Cl. Clear? That can only be formed if HCl gas is present. Okay, this is also the test for HCl. Okay, that is one of the observations that you need to read from here. Next observation for CO2 I have already told, H2 I have already told, H2 is also already told, SO2 already told. Okay, next one of the good observation, that is Na2SO3, this is sodium sulfite. If you add it with HCl and heat it, then you will get is NaCl, one of the respective salts, and H2SO3, that will not stay as H2SO3, it will dissociate to form this person. Right, observation goes with this. because you have no observation other than this. Okay, okay, this is fine. Now another compound is there, that is Na2H2O3. This person, if you add it with HCl, you will get NaCl, fine. You will get H2O, fine. You will get SO2, that also fine. But you will get another person, that is Mr. S. Clear? So often question comes as differentiates between these two person. How will you differentiate? So you have to add HCl. If you find this person, what is the observation for this person? Yellow deposit. Okay, yellow deposit. If you find yellow deposit of sulfur, then it is this person. Otherwise, it is sodium sulfite. Clear? It is sodium thiosulfite or it is sodium sulfite. Differentiation might come in question. Okay, next one. Next one is, what will happen if you heat AgCl? AgCl, if you heat it, no need to heat it, just keep it in light. Okay, no need to heat, light. What will happen? Ag will form and Cl will form. This will dissociate. Everyone knows that. So we will write the observation as this product. Okay, we will write the observation as this powder. It is black powder. Okay, metallic silver is a black powder. Clear? Now this AgCl is formed upon reaction with AgNO3 and HCl. That is also used as a test. Okay, it is also used as a test in ammonium hydroxide solution. Why? Because this person is soluble in ammonium hydroxide solution but not soluble in nitric acid. Okay, understood? So these are the observations that you need to remember from this part. Okay, next is one observation that you have is a very important question also, an observation also, that is the last observation that we are going to do this video, that is NH3 plus Cl2. Okay, one time this person in excess, another time other person in excess, that is chlorine. So NH3 plus Cl2, this time chlorine is in excess. Products will be different, as I have already told also in the video, that products will be different in both the cases. In the first case, where ammonia is in excess, the product will be ammonium chloride, right? So product will be ammonium chloride and this person. But where chlorine is in excess, product will become NCl3 plus HCl. Okay, this has an observation, yellow color. Okay, this person you already know, dense white fumes. Okay, dense white fumes. Okay, so dense white fumes of this and yellow color of NCl3 is formed upon reaction with this. Clear? Understood? So that was all that I had to say in this video about observations. Hopefully I have covered all the observations. Hopefully, I am not pretty sure also. So hopefully you also have enjoyed watching the video. See you all in the next video that might be coming soon.